welcome to today's lesson on Learn All Things Cyber with T. As I promised that we'll be focusing on subnetting today. Last week we did something around IP addressing. We looked into what IPv4 is. We looked into simple mathematics calculation on how to distinguish, how to convert from dotted decimal into binary format. And today we'll be focusing on, subnetting, CIDR notation. We would also look into a few examples on how you can calculate your subnets, on how you can know how many hosts are usable, on how you can also pick out the network address and the broadcast address. So stay tuned with me. So like I said, that today we'll be looking into subnetting. But before we go into subnetting, I'd like to explain like simple term to you, because last week we looked into the classes of IPv4, and then we talked about how we have class A, class B, class C. We also mentioned a little bit about D and E, which are kind of reserved, like I said last week. But we know what class A is, we know what class B is, and we know what class C is. I'll quickly refresh your brain so that you would remember what I said last week about all these classes. We mentioned that the classes are distinguished by the first number, the number of the first octet. And so we mentioned that for class A, we usually have it from 0 to 127. Class B, we usually have it from 128 to 191. For class C, we usually have it from 192 to 223. As I mentioned, that these are the ranges for the first octet that determines the class A, class B, class C. Now, I would quickly like to mention that we actually used to refer to this class as being classful. And then the other part of it is classless. So these are classful. And then we have the opposite of it that are not confined to a class as classless. So this brings us to what we call CIDR notation. And so CIDR notation is classless inter-domain, this is the routing. So I would explain it, I will show you so you'd understand. So for class A, if you remember, for class A, I mentioned that the default subnet mask for class A is usually like this, 255.0.0.0. That's class A. For class B is 255.255.0.0. And for class C, it's 255.255.255.0. So, and if you remember properly that I told you that those with the ones are for the network part, and those with the zeros are for the host part. So for class A, this is the network part. This is what the host can take up, the bits that the host can take up. For B, this is like the bits that the network can take up, and this is like the bits that the host can take up. For class C, this is the bits that the network can take up, and this is the bits that the host can take up. Now, when it comes to the CIDR notation for these ones, they are like, remember we said that every octet is like 8 bits. So for class A, the bit here is 8. This one, the remaining part is 24, right? Remember the sum is 32 bits. 8, 8, 8, 8, that's 32. So now the CIDR notation for A will be /8. For B, it will be /16. And for C, the popular C, it will be /24. I'm breaking it down a little bit so that you would understand. So this one is for the classful. Now for the CIDR notation, you could have even IPs that are /22, /27. So how then do we calculate the number of hosts and the number of, the number of bits for the host and the number of bits for the network? And that's why I just briefly explain what this is about. Now, I will pen this a little bit and we'll go to what is subnetting. So subnetting is like having a big network and you're trying to separate it into smaller network. And why do we do this in subnetting, in networking? We do this because we wanted to have a clear path into the traffic of the network. So for example, we mentioned in class C that you have reusable IPs that are like 254. But normally, if you have like an home setup, home devices, maybe all of the devices you're using in the home are like 10. Why do you need 254? And this is the reason why we do, subnetting. Also, subnetting is really very good when it comes to security. So, for example, let's say all the floors in this house, we have subnet division when it comes to the IPs that are being used in the home and everything like that. It's easy when there is a bridge to segregate or to isolate that part of the network instead of having the bridge go through the whole network. And this is why people use subnetting. I hope you understand this. And so how does subnetting work when it comes to IP? I would give you several examples, also based on what we've talked about previously. So say for example, works in real life, how subnetting works, how you can divide a large IP into subnets and finding the usable host IP from those subnets, and removing the broadcast address one, removing the network one. So let's begin from the simplest form that I taught you guys last week. Let's say we have an IP 192.168, 1 and 0. Normally, if it's a class C, we said something like the CIDR notation for class C is /24. So let's say /24. What does this mean? This means that the subnet mask, the default subnet mask would be 255.255.0. That's what it means. And how does this 0 come in place? It means that all of this is for the network, this is for the host. So 24 bits for the network and 8 bits for the host. So this is why we have /24. This is simple. This is classful. But then when we start to move to the ones that are not, that are very flexible when it comes to the number of IP they can take up, then it becomes a little hard. And this part also comes out in exam, because they will ask you the total IP, then they will ask you the usable IP, which is different. The total IP is always -2 to get the usable IP. So let's dive into those little bit difficult example. Please brace up. So let's say, for example, that this IPv4 then have a /25. How then do we calculate the network part? How do we calculate the host part? Remember I said that everything zeros is the network. Everything ones is the network. Sorry, I keep mixing up. Everything with 1 is the network. Everything with zeros are the host. So for this one, I will just take it step by step. Now we have 255.255.255. Then what are we supposed to put here? We don't know, right? Now let's go back to our binary, how we were calculating the binary part when it comes to subnet mask, right? So we said that all of this is 1, 1, 1, 1, 1, 1, 1, 1. 8 of it. And how did we arrive at this one? Remember that number I wrote for you: 128, 64, 32, 16, 8, 4, 2, 1. If you calculate all of this number together, it will result in this total. So we have, everything is 1, 1, 1, 1, 1, 1, 1, 1. That's how we arrive at 25, and this is how I arrive at this one that we have. So we have the same here, 8 times. We have the same here, 8 times, right? Now, because this is no longer 24, we have an addition of 1. So when you are calculating it in this case, you start from the beginning, from your left-hand side, the way I wrote it. So to calculate what is /25, we would put 1 here, and the rest will be 0, because of course it's only 1 we need to make it 25 to add to the network part, because the /25 is for the network, it's for the bits of the network. So in that case, because this is 1 and this is 128, then we have .128. So this is the subnet mask for this IP with this CIDR notation, as opposed to if it's 24, then it's 0, because the network is not eating into the host part. Now, in this case, this is the right answer: 1, 0, 0, 0, 0, 0, 0, 0. So this is how it looks. Now, how then do we calculate, in this case, how many hosts can we use? Remember we said in the previous classes that in the case where it is /24, then we have usable hosts that are like 254. Now we're saying in an apartment, in a department at work, you want to segregate what HR is using from what finance is using, from what payroll is using, right? That's the aim of subnetting. So in that case, in the case where we want to separate it, that means we have to calculate the group we have to calculate usable IP for each group, and then get, of course, the network address and the broadcast address, which is -2. Now, for this case, we already have this. Now, how then do we calculate the usable host we have? Don't forget, we already have 7 bits here for the host, because out of the 8 bits for this octet, the network has taken a part of it. So we have 7 bits. So in that case, the total IP that can be used in this case is always equals to 2 raised to the power of these 7 bits that is left. That's the total IP, which is equals to 128. You can calculate it. There is also another trick to calculate it. Once you know this, the last octet of the subnet, you can easily say the total IP is equals to 256 rather, minus the last octet of the subnet mask rather, and then you will get 128. So this is the total IP you can use. This is the total IP rather. Now the IP that you can use has to be the total IP minus 2, which will result in 126. And why do we have this 126? Because for every group of subnets, you have to remove the IP that will be used by the network itself, and then the IP that will be used for broadcast address. I was explaining what broadcast address was in the last lesson. Now let's, with all of these small calculations, we have already established the fact that we have 126, right? So let's go back to how that look in real life, right? So we have this IP 192, 168, 1 and 0, and we said we can use, usable IPs that we have is 126. So in that case, if we want to divide it into subnets, so the subnet 1 would look like this. For the network address itself, it will take up the first IP, which is 192, 168, 1 and 0. Now, because we said 126, right, for usable host IP, don't forget, it's the host we're trying to calculate now, like your laptop, your devices at home, in the department, all the laptops that people bring to work in that group. So now the usable host IP will be equals to 192.168.1.1 to, so this is to 192.168.1.126. This is the last one because of 126. Now the broadcast address for this group, it's a subnet. So we're calculating subnet for a particular group or maybe for a particular home appliances that you have. So the broadcast address will take up the last part, which is 192.168.1.127. And this is the total of that 128 that we have. So 127 plus this is also 1, even though the last part is 0. You understand that this is a single IP, plus this one as a single IP, plus 126 makes up 128. Now that's not all. This is just one subnet. Don't forget we said 126, right? So at the end of the day, if you have 255.255.255.128, right? Our achievement is to get to use the last point, which is 255, right? To use this last octet and finish it. Now we are just at the first one. So the second set of subnets would look like this. 192, the network will be 192.168.1. You remember we have the last one as 127, Nabi, to make 128. So the next one will be 128. This is the network one for the next subnet. Let's say this is for HR and we are trying to create the one for finance in this group. Now this is for the network. So the usable IP, again, let's calculate it. The usable IP will be equals to 192.168.1.129 to, don't forget, to 192.168.1. I think 254, if I'm not mistaken. So the total between these two has to be 126. So I'll check if it's correct. Let me see. Minus this is 71 plus. And then the broadcast address is the last one, like we mentioned, will now be 192.168.1.2 55. As I understand that networking is a little bit tough topic, I'm trying to, break it down as simple as possible. So I will just give a summary of what we just talked about. We're trying to break a big IP into subnets. And why do we do this in cybersecurity or in networking? We do it so that we can have a clear view into the network traffic. We do it because of security. When there is a breach, then we can isolate quickly that group where the breach is. Say, for example, you're in a big company and there's a subnet group between the finance, the HR, the manufacturing departments, and all of those. If there is a breach and they discover that the employee that, had a breach on their laptop belongs to a particular subnet, they'll quickly isolate that subnet from the whole network instead of having to have problem with the whole network. And this is the purpose of subnetting. And I was trying to explain how that we could have IP for class A, for class B, for class C. Like I was mentioning that for class A, the host you can use like 16.7 million. Why would you need that amount of host? For class B, I think it's like, 65,000 plus. For class C, it's 200 and something. And because you might not even need as much, host IP like that. So Subnet helps us to actually not waste IPs, but rather restrict ourselves to the usage of IP. Say, for example, you need 50 IP. Then you can stay on, let's say, 62. It makes sense than to go to class A and go and use 16.7 when you need 50 IP. And this is what subnetting looks like. And when you have questions in Security Plus and the rest, the calculation I just did is how it usually looks like. They ask you, look at this IP with the CIDR notation or whatever, with the subnet mask. Try to calculate the usable IP or the total IP. Like I said, the total IP is always -2 to get the usable IP. Now I want to state a second example so that you have a better understanding of how it looks like. So again, I'll use the IP I used initially. So 192.168.1 and 0. Initially we did /25, right? And we said that /25 means 1 bit from that host octet region into the network region, and I try to explain. So we need to do like /26 in this case. So what does /26 means? The same thing. We have 255, 255, 255, right? But we don't know what is supposed to be here. Now let's try to calculate what is supposed to be there. Again, 128.64, 32, 16.8.421. Now 26 means that we have 2 in addition, right? 2 means 1 and 1 from the host into the network path. Now these other ones will be, 0, 0. So what does this mean? The addition of these 2, which means 192. So in this case, we would have 192. So how then do we calculate, the total host from this? It's very simple. Like I said, we already know that this is 26, and normally the whole octet is supposed to result in 32, right? So 32 minus 26, we have 6. And to calculate the total host, it's easy. Total host is equals to 6, right? 2 raised to power 6. And then what does that give us? That gives us 64, right? And you can even calculate it from here, actually. It's easy to calculate it from here also. You can calculate it by one moment. So it's almost the same. So we have these 6 of them, 6 bytes, If you don't want to calculate it through this place, you can also calculate it that we have 6 bytes that belongs to the host, and then 2 raised to power that 6 bytes give you 64. This is the total host IP that we have. Now the ones that we can use. So usable host IP will be equals to 64 minus 2. Remember, we said this 2 belongs to the network address and the broadcast address. So we have 62. Now this is the block size for every subnet. It means that for every division of subnet, this is the maximum we can have. Remember the initial one, we said the amount that we can have for every subnet is 126, right? This one is only 62 usable host IP that we can have per group. Now how that works is that the higher you go with the network bytes, the lesser usable IP you can use, and the more subnet group you can have. I don't know if that makes sense. Now I'll go again. Now the higher network bits that you can use, the lesser the usable IP and the more subnet group that you can have. In this case where it was 126, the network bits was lesser, the usable IP was more, and we had just two groups. Remember, when I was putting the subnet together, I was only able to calculate two groups to get to 255. Remember, the aim is to get this point to 255. That's how to divide it. Now, let's start with the division. Remember, we have 62, right? 62 usable host IP. Now, 62, right? So the first subnet that we can have would look like this. This is network, usable, host IP, and this is the broadcast address. So for the network, we can have same way, 162.168, 1 and 0. The first IP always belongs to the network. Now, for the usable one, we can have 192.168.1.1 to. So this to means that the next one will be 192.168.1.2, 192.168.1.3, 192 to 192.168.1.62. Remember. And then this last one will be 192.168.1.63, right? And all of this makes up that total 64. With the usable IP, just 62, right? We have done one group of subnet. Let's say this one belongs to Orile Gomu. I'm just using an example. Orile Gomu, right? So now let's go to the second one. And this is how the second one would look like. It will be from here. The network will take up 192.168.1.64. This is the first one. Now the second one will be 192.168.1.65 to. So the to again also means that .65, .66, .67. So we are calculating it till it's 62. So the next one will be 192.168.1. This plus this will give us 127, right? 126 in that case. And the last one will be 120. So if you calculate everything together, it will give you this 162, right? And the last one will be 168.1.127. This is another part. Don't forget, we are trying to drive the last octet into 255. That's how to calculate the group. That's when you know you have arrived at the last group. Now, let's say this one is Mushiolosha, right? I'm just writing those. So the next one will be 192.168.1.128. This is for the network. You can't use it for host IP. It belongs to the network, right? So the next one will be 192.168.1.129 to 192.168.1. Now 62 again added to this. It will be 71, right? 62. No, which is 190. If you write it out, you discover you have 62, right? So this last one, the broadcast IP will be 192.168.1.191. You remember, we have not gotten to 255. So the next group. So let's say this one is what? Is Ibutemeta. By the way, I'm from Ibutemeta. I grew up in Ibutemeta. So this is for Ibutemeta, right? So the next one, we have 192.168.1.192. This is for the network itself. Nobody can use it. You can't use it for your laptop. Your laptop can be dynamically assigned this IP. Or even if you are doing it statically, you can't do it. You can't have the network IP. So the next one will be 192.168.1.193, right? To 192.168.1. Let's add 62 to this. It will be 55. It will be 55, right? 255. So this is 254. If you write it out, you discover it's 62. And then the glorious last one will be 168.1.225. Can you see? So in this, we can have four groups. So let's assign the last one to be my 12. So as you can see, we can separate this IP into four groups instead of using all of this, at once. What I mean is, when we have 24, then you'll be needing, at once to use all your 254. But instead of that, you can actually have this flexible CIDR notation and use it to separate it into, 4 different groups. that can be used differently, and you can also have a view into the security of each subnet. You know, you can isolate some part of the group and leave the others and all of that. So I hope this class is not too stressful for your brain. It's tough, I wouldn't lie, but the question usually comes easy. You know, they can ask you, they can give you this type of IP with this /26 and ask you for the usable IP. Very simple. Just, you know, 32 is like the overall octet. Just minus 26 from it, we have 6. So you have 2 raised to the power 6. We give you the total IP minus 2. Then that's the usable IP. You don't even have to go through all of this. Those are the trick. You know, also, I think I have another trick that when you want to know the range that you will have per each, each subnet, they ask you what is the block size of each subnet. It's very easy.
So to calculate the block size, it will be 256 minus the value of the last octet in the subnet mask.
Block is that easy. So I hope this explains all that you need to know about subnetting. See you next time. Thank you.